Alright, this recording is for Module 8 practice test. If at any time you feel like I'm going too fast, just remember you can pause it, catch yourself up, and then hit play and keep moving. If you have any questions, let me know. Alright, number 1, for f of x equals, under the radical 8 minus 2x, find f is negative 14, and then b, find the domain of f. Alright, so first thing when we want to find f is negative 14, remember that's just telling you that x is negative 14. So we're just going to plug in negative 14 where there is a x and then solve it. Alright, so order of operations says do multiplication first. Then we're going to bring everything down. 8 plus is 36, so the answer to A is 6. And then if we want to find the interval notation, we're just going to solve what is under here, set it to 0. We want it to be greater than or equal to 0. We don't want it to be anything less than 0 because you can't find the square root of a negative number. So we'll solve this. Yeah, remember when you divide by a negative, you flip it. So your x has to be less than or greater, or less than or equal to 4. So if you have a number line and we have 4 on here, we want everything on this side for this to be greater than or equal to a 4. So how we write that in notation is our smallest number could be negative infinity, and then we can go to 4 and we want to include 4, so we use the bracket. Alright, number 2, simplify the expression. So it's the cube root of negative 1 and 1/25. So we can find the cube of 1 or negative 1, and that would be 1. And we find the cube of 125, and that would be 5. And that would be a negative because you would do a negative, negative, and negative, and it would end up being 1 and 1/25. Alright, number 3. The cube root of 8x times the cube root of 11x squared. So as long as these are the same roots, you could just multiply what's underneath. So 11 times 8 is 88, and then x squared is x3. So remember, you just add them. Now we can actually simplify this a little bit better. So we can break down what's on the inside. Usually I try to find things that 88 can break down into that would be in groups of 3. Also, you can kind of do the factor tree. So we have 2 and 44, 2 and 22, 2 and 11. So we could rewrite this as 2 times 2 times 2 times 11. And then x3 is the same as x, x, and x. So this is like the broken down version. Alright, so the cube root is groups of 3. So there's one group of 3, that's coming out. And there's another group of 3, so that can come out front. And then what's left is what stays on the inside. Alright, number 4. We want the 5th root of y18. So we can write it in terms of 5. So we have, there's 10, there's 15, and then we have 3 left over. So if you pull this out, that's a y, and another y, and another y. So there's 3 of those. And then what's left stays on the inside. Alright, Number 5, we're dividing two polynomials. We can, since they are the same, kind of all put them underneath 1 and then simplify it. So remember, when you're dividing, it's subtracting the exponents. And then since we're talking cube roots, we can take 1x out because that's in the group of 3, and then there's 2 groups of y, and that leaves absolutely nothing under the radical sign. So that's our final answer. Right, number 6, as long as we have the same radicands, we can add them, but since we don't in this case, we're going to try to. So let's break down 18. So square root of 18, we can break that down into squares. So if I start like this, I can find the square root of 9, which is 3, so that can come outside, and I'm left with that. So we have 21 radical 2. That's how our 7 radical 18 breaks down. And then we can break down our 8, trying to find square roots, numbers that equal 8, so we can do 4 times 2, because we can find the square root of 4, which is 2. So then we have 10 radical 2. Now our radicands are the same, so we can just add the numbers on the outside. So that is 31 radical 2. Okay, number 7, that is a FOIL problem. So just remember, it means to do it twice. First outsides, insides last. Alright, so anytime you multiply 2 identical, it's just the square root of 2 squared, which just comes out 2. Radicand of 2, radicand 7, that's radicand 14. Same thing. Then outsides, we get a 7. Combine our like terms. And then make sure this can't be broken down anymore, so that we could take a square root out of it, but all that we can do is 2 and 7, and we can't find a perfect square root of 2 or 7. So this is your final answer. Right, number 8, same thing, we're going to FOIL it. So 6, and then radical 2, that is just 2. And this is 3 radical 2. And this will be 30 radical 2. And then 5 times 3 is 15. And then we're going to simplify it. Since these have the same radicand numbers, we can just add them together. And then combine our constants. Number 8, rationalize the denominator and simplify. Alright, so we want to multiply by something that makes this come out perfect, where the radical will be gone. So right now we are missing 4 other x's to make this perfect. So that's what I'm going to do. I'm going to do 4 more x's. What we do to the bottom, we got to do to the top to make it equal. Right, so now on the bottom we have this, and I'm sorry, my numbers are very small. So this can simplify, oops, I forgot the 14, sorry. This can simplify to just x, and then the top we can do absolutely nothing to, because to be able to get anything out of here, this would have to be 5 or larger. So that is our final answer. All right, number 10, we're going to multiply by the opposite. And you do this so that your middle term will cancel out. So first would be x. Insides, outer, last. And then the top, x minus 3x plus x minus 3. So we don't want a radical sign in the denominator, so that's the reason we do this. Then we're going to simplify it. So on the top we have x minus, and you put these together, that's 2. And in the bottom, these cancel out and leave just this. So our whole goal was to get rid of the radical sign in the bottom in the denominator, and that's what we did. Alright, number 11, rewrite using rational exponents and simplify if possible. Alright, so if you remember, the denominator is what is on the outside of our radical. So this is really all they wanted you to do. If there's an exponent, it still stays as the numerator, and then whatever your guy is out here becomes your denominator. Right, number 12, this is x to the half times x to the third. We need to add our exponents since we have the same base. So we need the same denominator. We get 5/6, so our final answer is x to the 5/6. Number 13, rewrite using radical notation. So basically we can take this whole thing, and the bottom number is what goes out here. Now if there was something in the top, then we would give each one of these that exponent. Alright, number 14. So we have a negative exponent, so that's the first thing we want to take care of, is let's put it in the bottom so that we can get rid of the negative exponent. And then we're going to go ahead and simplify this. So we know it's going to be 1, and the bottom number, that's a 2, but we don't write it when it's like this. And then we just do 25 to the third, and we can actually simplify this. So this would actually be 1 over square root of, let me see what 25 thirds, oops, sorry, 25 times 25 times 25 is 15,625, and then the square root of 15,625 is 1 over 125. Alright, number 15. So the bottom number goes out here, and then this would be to the third power. So first thing we would do is do the negative 32 to the third power. And that's negative, negative, negative. Makes this. And then the cube root, or the fifth root of a negative 2048 is negative 8. And you can punch these in your calculator. I don't expect you to know those. Alright, number 16. To be able to combine these, since we have the same base, we're just subtracting our exponents. So this is y to the 1/7. want to put it in the form, either one. That's what it looks like. Number 17. So let's simplify the top first. We're squaring everything, so 3 squared is 9. And then we have y to the third. Let me write this kind of over here. Y to the third squared. So if you remember the rules for raising a power to a power, you just multiply the two. So we have y to the 2/3. And then on the bottom we have y to the 5/12. Since we still have y's on the top and bottom, we can go further. We want to subtract our exponents. We have to have the common denominator. And I get 9y to the 4th. Alright, number 18, perform the indicated operations if they're complex, write in an a plus bi form. Alright, so this one we're just subtracting our second. So I'm going to take the parentheses off and go ahead and give the negative to both of them. Since the second one is already negative, it becomes positive. Then we can combine our forms. So we have -7 and -6i. And then make sure it's in the a plus bi form. So just written in the right direction. Alright, 19, we're going to distribute. 4i times 3 is 12i. 4i times -5i is 20i squared, negative. We can simplify this further because we know that I squared equals -1. So we have 12i minus 20 times -1. So we can bring this out further, which is 12i plus 20. And then we want to make sure we write it in the right form. The constant goes first. Alright, 20 is a FOIL problem. So first is -35i. Outsides is -35. Oh wait, sorry. First is positive 30. Outsides -35i. Insides is positive 24i. And then last are -28i squared. So we're going to combine like terms and simplify our I squared. So we have 30 and 35 plus 24 is 9 minus 9i. And then this is -28 times -1, which is positive 28. If we combine, I'm sorry, wait a second, where did I get 9? This is actually 11, -11. Let me write that again. Sorry, I didn't add correctly in my head. Then we put these two together, we get 58 minus 11i. Alright, 21. The only way we can simplify that is to rationalize our denominator. So that means we're going to times by 2 plus 5i. When I do that, let's see, we'll do the top first. 14 plus 35i plus 8i plus 20i squared. Our bottom is 4. The insides will cancel out, and then we just do our last squares. If we combine our like terms, and just remember that this is -1, we have 14 plus 43i minus 20, and then remember this is -1, so 4 plus 25. So now we have negative 6 plus 43i, and on the bottom we have 29, and if we want it in the right form, we want to separate these out. So negative 6 over 29 plus, and we put these 43 over 29i. Number 22, we have I to the 50. Alright, so I usually just write I squared 25 times, because you know that I squared equals negative 1. So 24 times would come out as a positive 1, because remember, two negatives will come out as a positive. But the 25th time, we're left with just one I squared. So we have, these are the I to the 24, I squared to 24 times. That will come out as a positive 1 because two negatives, well, it's an even number, so they're always going to cancel each other out. But this poor guy, he's our 25th one, so that makes our answer a negative 1. 23, we want to use our square property. So if we square this and we square this, that gets rid of the radicals. But this side has 16 now. And then we're going to solve it just like in its own equation. So our answer is 6. So on this one, to be able to get rid of our radical, since it's to the third, we're going to make it to the third. That gets rid of everything, the radical sign. And then 3 times 3 times 3 is 27. Bring this over. So x is 5. So on this one, go ahead and bring this over. So it's minus 4. That makes it minus 3. Now we want to square everything. Alright, so if I square this, I get 2 squared, which is 4, and then the x minus 3 comes out of the radical. And then on this side we have x squared, and I'm going to FOIL this, so this is what I'm doing. X squared minus 6x plus 9. So that's our, if we do it the first outside, inside, last, and then combine our like terms. I'm going to go ahead and FOIL or distribute this. I'm going to try to get everything on this side. So if I bring my 4x over, now I have negative 10x. Bring my 12 over, now I have 21. If we factor this, I get 7 and 3. They both be negative. To be able to get that negative, set each of these to 0. So my answer is 7 and 3. If you have any questions, let me know.